Hello ladies and gentlemen. This video, it's a short video, starts you off with our very basic properties of a normal distribution, and one of those properties is called the empirical rule, or the 68, 95, 99.7 rule. So because a normal distribution is representative of our data distribution, it is very optimistic and idealistic. It's a normal curve, and obviously if we drew a histogram of our data, that the bars of the histogram would stick up above the curve and stick down below the curve. So a smooth curve is an idealistic view of what our data should look like. So we really can't use x bar and s that we get from our calculator, because we're assuming a more ideal situation that represents the population. So what we use for mean is it looks like an M, but it's actually the Greek letter mu. And for our standard deviation, instead of S, we use the Greek letter sigma. And it looks like a little circle with a tail sticking out of the top to the right. And that's the Greek letter sigma. Now down below on this particular screen you see that I have two normal distributions, and it shows that mu is all in a normal distribution. Mu is always in the center, and we're assuming that a normal distribution is symmetric, so also our median would be in the center, and we'll cover more of that later. Then when we measure a distance away from the mean, or the mu, we call that distance sigma. And you notice here that it shows a distance away from you on the right hand side, and that's a sigma. We also have it on the left hand side, that's a sigma. And the further that we get away from you, the probability of that event occurring gets less and less. We also discussed before that if we have a very small standard deviation, then our curve is higher. If our standard deviation is larger, then our curve is flatter, as you see on the one on the left, and we'll discuss more of that also. The 68, 95, 99.7 rule is the result of many observations and experiments, and there's also a formula that'll blow your mind. It's on the back of our Mathletes t-shirt, but it helps explain how this rule came to be. So in a normal distribution, if we go out one standard deviation, then 68% of all the observations fall within that one standard deviation to the left and to the right. So it's a total coverage of two standard deviations, but it's one to the left and one to the right. And that means that 68% of all of the people that we survey would answer in that particular, that we would get that particular answer for 68% of all the people we surveyed. Or if we did an experiment, 68% of the answer we're looking for would fall into that interval between -1 and +1 standard deviations from the mean. And so what we see is that it becomes very predictable at that point. So if we have something that is a normal distribution, we know that 68% of the population will fall within that range. If we go out two standard deviations away from the mean, we look and we see that's 95% of the population will occur, or 95% of our data will occur between -2 standard deviations and +2 standard deviations. So it's 2 standard deviations away from the mean, but if you look at our interval, it's from -2 to +2, which is a total of 4 standard deviations. So very often we refer to the 95% as being 2 standard deviations away from the mean, but it's 2 above and 2 below. At 99.7%, the observations fall 3 standard deviations away from the mean on each side. So we can confidently say that 99.7% of our results will be within that 3 standard deviations above and 3 below. Now look how many total standard deviations. I want to point this out early on, that's a total of 6 standard deviations from -3 to +3, because that'll come into play later on, and that'll help us quite a bit. Okay, and we're done with this, and it's pretty simple to go ahead and give you an example right now and explain that, and maybe that'll make things even clearer. If we look at the average height in the United States of women, that comes out to be 64.5 inches. was found. So, how much of the population is one standard deviation above and one standard deviation below? Well, we just said that. We've got 68% of the population. Well, how tall are those people from one standard deviation below to one standard deviation above? Well, our standard deviation is given up. So if we read that first paragraph, the standard deviation, sigma, is equal to 2.5 inches. Okay, well, we take our mean, we add 2.5 inches, we get 67. We take our mean, our mu, and we subtract 2.5, we get 62 inches. So we can confidently say that 68% of the women in our survey were from a height of 62 to 67 inches. Okay, 68% of our population. That's underneath the curve. That's underneath the tallest part of our curve. If we go out 2 standard deviations on each side, we're going to subtract another 2.5 inches from the left and add another 2.5 inches to the right. And so now our range of numbers the spread is from 59.5 to 69.5. So we have 10 inches there. And that tells us that 95% of our population will have heights from 59.5 to 69.5. And then once again, if we go out yet a third standard deviation on each side, then our 95% of our population will range from 57 to 72 inches. So that's 3 standard deviations away, and that's 99.7% of our population. I think I just screwed that up earlier. It's 99.7% of our population is 3 standard deviations to the left and 3 standard deviations to the right. Within those standard deviations, we see the bulk of our population, 99.7%. Okay, so this concludes the empirical rule, mostly known as the 68, 95, 99.7 rule. Thank you for your attention, and please continue with the assigned problems that you were given today.